This section is higher order derivatives, and there's really not a whole lot new here. You just take your first derivative and you then keep taking derivative. So let's look at our first problem here. Excuse me. Now, y is equal to 2x squared minus 5x. Instructions say find a second derivative. Well, for our first derivative, take a power, put it out in front, lower it by 1, minus, and remember a number with an x just becomes the number. So that gives us 4x minus 5. Then for a second derivative, we put two little tick marks like that, y double prime, and then we take derivative of y prime. Well, derivative of 4x minus 5 is 4. And that's our answer. Excuse me. Let's take a look at this one. We got f of x is equal to 5x to the negative 3. Find the second derivative. For our first derivative, take your power, put it out in front, lower it by 1, which gives us negative 15x to the negative 4. And then for our second derivative, take your power, put it out in front, lower it by 1. Negative times a negative is positive. 15 times 4 gives us 60. X to the negative 5. And we don't want any negative exponents, so we take the x and negative 5 to the denominator, and we get 60 over x to the positive 5. Let's take a look at this one. And, yeah, probably just do it right here. F of x is equal to x times the fifth root of x. And instructions are find second derivative. Well, I could use the product rule here, and then after I do the product rule, then probably use the product rule again. But this is one that we can actually simplify. The fifth root of x is x to the 1/5. Again, whatever number's in this little slot, that's your index, goes in your denominator. Now this is x to a power times x to a power. If I had x squared times x to the third, you would add your exponents. So I got 1 plus 1/5, which gives us 6/5. And now we're ready to start taking our derivative. So for our first derivative, take your power, put it out in front, and then lower it by 1. Which would give us 6/5, x to the 6/5 minus 1, that gives us 1/5. And then for our second derivative, same thing. Take your power, put it out in front, and lower it by 1. Well, 6 times 1 is 6, 5 times 5 is 25. 1/5 minus 1 gives us negative 4/5. These are again mixed numbers. I'm taking negative 1 times 5 is negative 5, plus 1 is negative 4, and then denominator stays the same. Well, remember, we don't want any negative exponents, so I take the x to negative 4/5 to the denominator, and it becomes x to the positive 4/5. And that's our answer. Let's take a look at this one. Got y is equal to 7, and then x squared minus 3x to the third power. Instructions are to find a second derivative of the function. Well, this is the chain rule. We got parentheses to a power, where it's more than just a single variable. Well, the 7 stays out in front. Take our power, put it out in front. What's inside the parentheses remains as is. Lower our power by 1, and then we multiply it times the derivative of what's inside the parentheses. Well, 7 times 3 is 21. And then we got x squared minus 3x squared. And then the derivative of x squared minus 3x will be 2x minus 3. And let me rearrange that a little bit. Put the 2x minus 3 in front. No particular reason. I just like the part with the square to be at the end. And that's our first derivative. Well, in this one, the second derivative isn't as easy. We have to use the product rule. So here we got something times something else. So that'll be P and that'll be Q. Well, for our product rule, we need P prime. So the derivative of 2x minus 3 is 2. And for Q prime, we have to use chain rule again. We take 2, put it out in front. What's inside the parentheses remains as is. Lower this power by 1, and then we multiply it times the derivative of what's inside the parentheses. So we got 2 times x squared minus 3x. Then derivative of x squared minus 3x is 2x minus 3. And that would be our Q prime. So our product rule, here's our y prime here. Our product rule is P prime Q plus P Q prime. So for our second derivative, the 21 just stays out in front, and it's going to be multiplied times everything, so I'll put a bracket. P prime is 2. Q is x squared minus 3x squared plus P. I think I flipped those around. Not that it matters. I'll wake up eventually. And then P was 2x minus 3. And Q prime is all this. So we got 2x squared minus 3x, 2x minus 3. No, actually, that is the way I had it before. Never mind. Okay, this is considered one group. This is considered one group. Why are they considered one group? Well, this is 2 times this. This is 2x minus 3 times this, times this, times this. So everything's multiplication in there. Okay, leave the 21 there. I'm going to factor out what they have in common. They both have a 2. There's a 2 and there's a 2. They both have a 2 in common. And they both have a x squared minus 3x in common. Now specifically this one has 2 of them, but this one only has 1 of them, so we'll bring out 1. So we've got x squared minus 3x. Now let's see what's left. We take that 2 away, we take one of these away, so that leaves us x squared minus 3x. Over here that 2's gone, this is gone, so we're left with 2x minus 3 times 2x minus 3. Well, a little bit of simplifying here. 21 times 2 gives us 42. X squared minus 3x. And here we got x squared minus 3x, and we'll multiply these together. 2x times 2x gives us 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 gives us a positive 9. So now, combine together like terms. X squared plus 4x squared is 5x squared. Negative 3x, negative 6x, negative 6x. That's negative 12, negative 15x. And plus 9. Now there's one last thing I can factor out. This x squared minus 3x, they have an x in common. So I can factor that out. And that gives us x minus 3. Typically, simplified form, and not all the time, some books are a little bit different about this. Typically, simplified form means if they have something in common, factor it out in front. And try to write it as a product if you can. Like this times this times this. But anyway, that's our answer. And that's probably... that's what the next problem says. Yeah, it's place for a new page. Order derivatives. Page 01, the PDF. Excuse me. Okay, let's look at this problem. Got y equals 1/12 x to the fourth minus 4/3 x to the third plus 15/2 x squared minus 2x plus 1. It says find a second derivative and solve the equation. Let's first do the first part. Find a second derivative. Well, take our power, put it out in front, lower it by 1. Take our power, put it out in front, lower it by 1. Take our power, put it out in front, lower it by 1, and negative 2x just becomes negative 2, and then derivative of 1 is 0. Well, 1/12 times 4 gives us 4/12, or 1/3. Minus, those 3's cancel and gives us 4x squared. Those 2's cancel and gives us 15x, and then minus 2. For our second derivative, number out in front just stays out in front. Take your power, put it out in front, lower it by 1. Take your power, put it out in front, lower it by 1, and 15x becomes 15. Those 3's would cancel, and we have x squared minus 8x plus 15 for our second derivative. And, yes. It's uploading a trig video I'd done earlier. If I can get back there, here it is. Okay, then it says solve the equation. So we're going to set our f double prime equal to 0. So we take what we just found, and we set it equal to 0. So we got x squared minus 8x plus 15 equal to 0. And this factor is using the PSD method. This is x minus 3 times x minus 5. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. And we get x equals 3, and x is equal to 5. And those are our answers to this particular problem. We're going to see that in the chapter, we get into working with concavity and point of diminishing returns. And we have to find a second derivative and set it equal to 0 and solve it to determine our concavity. That's where we're headed with that. They're just not random problems we're asking you to do. Well, let's take a look at this one. X square root of x squared minus 9. Same instructions. Well, in order to find the second derivative, I need to get rid of the radical, so I put it in the fractional power form like that, rational exponent. And that's a product rule. We got something times something else. So this is going to be our P, and this will be our Q. Now we need P prime and we need Q prime. I'll do them over here on the side. The derivative of x is 1. For Q prime, I have to use the chain rule here. We got parentheses to a power. Take our power, put it out in front. What's inside the parentheses remains as is. Lower our power by 1. And then multiply it times the derivative of what's inside the parentheses, which is x squared minus 9. So that gives us 1/2. X squared minus 9. 1/2 minus 1 gives us negative 1/2. And derivative of that would give us 2x. Well, the 2's would cancel here. And actually, let me show it. Okay, put 2x up on top, 2 down here. And the negative exponent goes downstairs. So that becomes a positive 1/2. And now the 2's cancel, and we got x over x squared minus 9 to the 1/2. And that's our Q prime. So for our first derivative, P prime we just said was 1. Q was x squared minus 9 to the 1/2 plus P, which is x, times Q prime, which is the x over x squared minus 9 to the 1/2. Well, I want to get a common denominator, So I'll put this over 1. So we got x squared minus 9 to the 1/2 over 1 plus x times x is x squared over x squared minus 9 to the 1/2. Okay. We need to get a common denominator, which since this is 1, the other denominator is our common denominator. So I'm going to have x squared minus 9 to the 1/2. And same thing here. This one already has that denominator, so we leave it alone. Here we multiply the bottom part by x squared minus 9 to the 1/2, so we have to multiply the top part by x squared minus 9 to the 1/2. Now x squared minus 9 to the 1/2 times x squared minus 9 to the 1/2, since they're the same, you add the exponents. 1/2 plus 1/2 gives us 1. So this would give us x squared minus 9 over x squared minus 9 to the 1/2 plus x squared over that. Well, they have the same denominator now, so I'll combine together the top parts. X squared plus x squared is 2x squared minus 9 over x squared minus 9 to the 1/2. And that's our first derivative, which f prime. Well, now we need to find our second derivative. And this is a quotient rule. So this will be p, and this will be q. And I'm going to do those steps up here. So p is equal to 2x squared minus 9. P prime will be 4x. And actually I didn't need to do them up there. But, oh well. Q is equal to x squared minus 9 to the 1/2. If I scroll up a little bit, we've already found that. That's this right here. So Q prime is equal to x over x squared minus 9 to the 1/2. It's the same thing as it was before, right? X squared minus 9 to the 1/2. We're just going to do something a little bit different with it this time. Okay, so our formula is p prime q minus p q prime over q squared. So for our second derivative, p prime, I'm going to have to scroll up here. P prime is 4x times q, which was x squared minus 9 to the 1/2, minus p, which was 2x squared minus 9, times q prime, which is x over x squared minus 9 to the 1/2, all over q squared. So we're going to have x squared minus 9 to the 1/2 to the second power. Okay. I'm going to simplify this a little bit. So I got 4x times x squared minus 9 to the 1/2 minus, and I'll put these together on top. So we got x times 2x squared minus 9 over x squared minus 9 to the 1/2 over x squared minus 9, 1/2 raised to the second power. You multiply the exponents together. 1/2 times 2 gives you 1. So this is x squared minus 1. Well, we can't have the fraction inside of a fraction, so we're going to multiply everything by x squared minus 9 to the 1/2. So I got 4x x squared minus 9 to the 1/2 times x squared minus 9 to the 1/2 minus x squared minus 9 to the 1/2 times this fraction, x times 2x squared minus 9 over x squared minus 9 to the 1/2, all over x squared minus 9 to the first power times x squared minus 9 to the 1/2. Okay, we're multiplying everything by the LCM of all our inner denominators. This is our only inner denominator, the x squared minus 9 to the 1/2. When we do that, those are going to cancel. I'm going to continue the problem up here. So for our second derivative, here we have 4x, so that remains. Now here we have x squared minus 9 to the 1/2 times x squared minus 9 to the 1/2. Since they're both the same, we're going to add the exponents. 1/2 plus 1/2 is 1, so that just gives us x squared minus 9. Back down to here, we got a negative x and 2x squared minus 9. And then down below we have x squared minus 9, and this would give us 3/2. 1 plus 1/2 gives us 3/2. Remember that they're the same, you add the exponents. Okay, let's get rid of the parentheses and combine like terms, see what happens. 4x times x squared gives us 4x to the third. I'm lying to you. I didn't think they had anything in common, but I see it now. They both have an x, don't they? So I can factor that out first. And that leaves us 4 times x squared minus 9 minus 2x squared minus 9 over our denominator. Now, 4 times x squared is 4x squared. 4 times negative 9 is negative 36. This negative out in front flips the sign of both of those, so it becomes negative 2x squared plus 9 over this denominator. Which 4x squared minus 2x squared gives us 2x squared. Negative 36 plus 9 gives us negative 27. Yeah, negative 27 over this. And that's our second derivative. Well, second thing we need to do, set it equal to 0 and solve it. Now, the neat part about this is when you got a fraction and you set it equal to 0, if you multiply both sides by this denominator, that denominator disappears. So basically, we just have the top part equal to 0. So we have x times 2x squared minus 27 equal to 0. This is already factored, so I can set each factor equal to 0. Set x equal to 0, and that one's done. And 2x squared minus 27 equal to 0. Well, here, take negative 27 on the right side, becomes a positive 27. Divide both sides by 2, and we get x squared is equal to 27 over 2. Square root property. Drop off our squared, put a plus or minus square root around the other side. Now, we can't have a fraction inside of a square root, so we'll split it up. Square root of 27 over square root of 2. 27 is 3 times 3 times 3. So I can simplify that one a little bit. I can bring a pair of 3's out as a single 3. And we can't have the square root downstairs, so we'll multiply top and bottom by the square root of 2. And since I'm about out of space, I'll go ahead and put it right here. And that gives us plus or minus 3 square root of 6 over 2. And those are our other two answers. And I didn't draw my line here in case you're printing these out. So let me draw a line where I'm continuing. So that continues right there. And that's the end of that problem. So let me save that page. Stop the recorders. This is higher order derivatives.